Let's solve LeetCode 90 subsets 2. Given an integer array nums that may contain duplicates, we want to return all the possible subsets. The solution set must not contain duplicate subsets. Return the solution in any order. So given the nums 1, 2, 2, the output will be an empty list because an empty list is a subset of the bigger list. Then 1 because 1 is a part, 1, 2, 1, 2, 2, 2 and 2, 2. The reason this is different from subsets question is because the input array can now contain duplicate elements, but the output still must not contain duplicate elements. For example, 1, 2 is given over here, so 1 and 2 cannot be taken from here, right? So if index 0 and index 1 is taken, index 0 and index 2 cannot be taken. That's because they are basically the same array. Now, a simple solution to this can be that you essentially do what you did in subsets. So let's recap what we did in the subsets list. We'll start off with an empty array. And by the way, I'll write down the array over here. 1, 2, 2 is our original input array. And then we have the possibility of including 1 or excluding 1. So if we include 1, we have 1. If we exclude 1, we have an empty list. Then we have again the option to include 2 or exclude 2. So I will include 2 and then I'll exclude 2. Then over here I have the ability to again include 2, exclude 2. Then we can do the same thing. So we have the ability to include 2 again. So that will give us 1, 2 and 2. And then we can exclude 2, which is, well, 1, 2. After that, we can again do the same thing. So here we can have 1 and 2, and well, we can just have 1 here. Then the same thing happens over here, but you get the point. Now, how is this different from the subsets question, right? And that is the problem over here. If you notice, this thing here is the problem. That's because we have a list that's present here, and they're essentially the same list. Now, how can we avoid this? Well, the very simple way we can avoid this is instead of storing the result in this list that's present, we can store it in a set, right? So if we store in a set, the thing would be that there would be 1, 2, 2, and then there would be 1, 2. And then when we try to again store 1, 2, it will not be stored, because as you know, there is 1, 2 present over here. It's present in a set, there will be no duplicates. But how do I ensure that the elements are always ordered? Because it can be the case that, you know, we add 2, 1 over here, for example, and well, they're basically the same list. So how do I avoid that? Well, to avoid it, initially itself, I can just go ahead and order the list. That means I'll call the sort on the nums array and we're done. That's how simply we can resolve everything. Now, if that is done, how am I going to store the element in the array? You cannot store a list within a set because list is not hashable. Sets can only store hashable materials. So you can convert this into a tuple and well, you can do it. And then you can return the answer. Python will automatically convert it to a list behind the scenes and it will all be done. It will work as well. The problem is we can do better. So this is not a wrong solution, but whenever you have to do these kind of things, you can genuinely think that you'll be asked to optimize this even further. So how can we optimize this? Let's think about it. So if we come back to this approach that we have, or let me just have one like that. Okay, let me just have this. So whenever you have this kind of thing, what you want to do is notice that when you have 1, 2 here, you have 1, 2 here, correct? So that means if it's happening in the right hand side when we are excluding, it is happening in the left hand side when we are including. So what we can do is when the inclusion is done, the element is in the array, we can always say while we are excluding that, hey, listen, I don't want any duplicates. So let me not include it, because this is the pattern. For example, let me elaborate this. Let's say we have 2, right? Now you can either have another 2, so 2, 2, or you can just have 2, correct? Now here you can again have 2, or you can have an empty list. Now, as you can see, this is the excluding part and this is the including part. So whenever you have it, whenever you have an element in the including list, whenever you're making a decision of including and putting that in the result, you will also have an excluding list, and excluding and including can probably be the same. Whenever you try to include stuff, both the including will never be the same. For example, like think about it. You have 1, 2 over here and you have 2 here. Like if you want to include the next element, they can never be equal, because when you're including stuff, you're adding stuff. So you've already taken care of each of the elements. For example, when you want to add stuff here, so you have added 2 to the empty list, it will not be equal to any of the including parts, because every time you're including, you're adding something new, and 2 is not going to be it. So that is the thing. This is the thing we're going to take advantage of. Whenever we have included it, we are going to, after that, put a check that, hey, if this is a duplicate, we don't want to go ahead with this. And obviously we'll have to sort the list to know if we have a duplicate or not. So the very first thing is nums.sort. After that, I'll just backtrack. I'll create a path. I'll create an index. And then the very first thing I'll do is, well, I just want to check that, hey, if the index is greater than the length of the nums, or if it is even equal to the length of the nums that I want to store. So as soon as we have hit the limit of length of nums, then I'll just store it in a result variable. So let's go. And then I can just have result.append, and then I'll append the path till here. And I'll just put a colon here. By the way, again, index over here just represents the depth of the tree. So here the index is going to be 1, I believe, or 0, whatever. Then here it's going to be 2, and then here it's going to be 3. So that's how the index is represented. Then we'll return. Now, again, if you want to hyper optimize, go ahead, put another elif condition. That's fine too. After that, what we want to do is just append to the path. So I have path.append nums at the index, right? Because initially the index will be 0. So I want to append the first element from nums and put that in. Cool. After that, I'll call backtrack with the path passed in, and the index is going to be index plus 1 because I want to move to the next element. So I move to the next element 2 here. After that, I can simply go ahead and do path.pop. Cool. Classic backtracking. After that, this is all the inclusion stuff. So this is like whenever we want to include anything, we are adding 1, we are adding 2, we are adding 2. And as soon as we hit the base case of index being the length of nums, we are returning out and we are popping off the element. So 2 is being removed from here. And then we hit another case, which is 1, 2. 1, 2 is just the array remaining as it is. So whenever we have the exclusion part, or whenever the array is being itself, what we can do is just backtrack path with index plus 1. So here the path is just 1, 2. The element is not included. So element excluded, and let's call this element included. All right. After that, we don't have to pop anything because we already did not add any element in the path beforehand. But before we go ahead, I want to ensure that, hey, I'm not stepping over any of the indexes. Like we are not duplicating anything, because if we have included it, we want to ensure that no exclusion part gives us the same array. So we'll skip over the duplicate elements. So what I can do is while the number, So it's going to be nums at index is less than, or I don't think we want to check for less than. If it is equal to nums at index plus 1, then what we want to do is, well, simply index plus equals 1, right? Because we want to move ahead with the index. And then I also want to make sure that we keep going as long as the index is less than the length of the nums and this. Cool. So this will allow me to stay in the bounds, and we'll just keep incrementing index as long as it's present. And then this will ensure that we have no duplicate elements. We'll backtrack and it's done. So I can simply return the result. Let me call backtrack here. The path is going to be an empty list. The index is going to be 0. And that's pretty much it. Let's run it. And by the way, we can only check the duplicates because nums.sort is present. Great. Now we are getting the list index out of range error. That is probably present because I obviously checked index is less than length of nums, but I've not checked index plus 1 should be less than length of nums. That's because, you know, nums at index is equal to nums at index plus 1. So index plus 1 has the capability of going out of bounds. Index will never be out of bounds because index is equal to length of nums. Let's run it again. And now we see that it works. Let's submit it. And that works as well. Now, the one thing that I want to do is re-go through this again and tell you why that works, give you an intuition of why that works. So we have 1, 2, 2. We start off empty. Then we have either including 1 or not including 1. Then including 2 or not including 2. So there we go. Now again, including 2 or not including 2. So that gives me 1, 2, 2 or 1, 2, and then including 2 again. So we have 1, 2. Remember, we have included 2. So inclusion is allowed, but in exclusion, that's when we are checking if we have any duplicate elements, right? So this is fine. Now we come over here. Let's check this. So we add index 2 here, or actually, I think we only have to add 2. Now here we again go through the inclusion. Now, do we want to add another 2? Sure. But now the exclusion part is 2, correct? That's fine too. Now we have an empty array. We can include 2. But here's the thing. This part shouldn't be added because we are in the excluded part. So before this part executes, which is when this thing gets added, we're simply checking that, hey, while the index plus 1 is less than length of nums, so what index are we on? Well, let's say we are on index 1. Well, 2 is less than 3. That's correct. So the length of nums is 3, right? So 2 is less than 3. That sounds right. And nums at index is equal to nums at index plus 1. The index is 1, right? So if the index is 1, index plus 1 is again 2. And if index at 2 is 2, that means like we are essentially checking this and this item. If they're equal, what we want to do is index plus equals 1. So we go to the next element of the nums array and we just increment the index. So we essentially skip out on the element, and this will make sure that we're not adding this particular thing. This will allow us to add 2 in the inclusion part, and in the exclusion part, we can simply just have this. The same thing happens over here as well. What happens is we are in the exclusion part. Again, we run those checks and 2 is not included again. So, well, we'll remove it from the exclusion part. It's never added. And we have 1, 2 over here in the inclusion. So that's what this while loop is doing. And it only works because we are guaranteed that the nums is sorted. If the nums is sorted, all the elements are in increasing order. So index and index plus 1. If they're equal, it means they're the same element and they can be closely located, or they will be closely located if they're the same element. So yeah, that's the solution.